So, hello guys, today we are going to solve problem number. Okay, I forgot the problem number. Eh, Okay, so I need to check what is the problem number. I think 1547. Okay, 1572. Okay, so if you like my video, please do share, like, and comment. Okay, I'm going to share my screen that you can check how I am going to solve. Okay, so this is the problem 2D list diagonal sum, LeetCode problem 1572, and the problem given a square matrix, return the sum of the primary diagonal element. Okay, so here if you want to search, mm, if you want to search the problem here, LeetCode 1572. Okay, so this is the problem. Mat 1572 matrix diagonal sum. Okay, so here you can see give a square matrix mat, return the sum of the matrix diagonal. Okay, so we are going to return sum of these diagonals 159. Okay, and only include the sum of the all element on the primary diagonal. Okay, so we are going to take all element from the primary diagonals. Okay, and all the element of the secondary diagonal that not a part of the primary diagonal. Okay, so we can take a secondary diagonal also, but we cannot take this 5 because this is the part of uh, first primary diagonal. Okay, so here we can add it one time, not twice. Okay, so it appear twice. It is also upper in a primary diagonal, and it is also part of secondary diagonal. Okay, so here you can see output equals to 25. Here diagonal sum equals to 1 plus 5 plus 9. Okay, and here you can see 3 plus 7, this 3 and this is 7. Okay, equals to 25, and we are going to add 5 only one time. Okay, so notice that the element matrix one by one of one 5 is counted only once. Okay, so 5 only counted one. Now this is also our matrix 4 by 4, output equals to 8, and here matrix 5, output equals to 5. Okay, now I'm going to check dry run of this matrix. So here you can see we are going to calculate diagonal. Okay, so here n equals to length of matrix equals to 3 because we are going to take this 3 by 3 matrix. Okay, so here first of all this is the formula mat I n minus n minus 1 minus I. Okay, pick the element from top right bottom left. Okay, so like if you want to find out these diagonals. Okay, 3 5 7. Okay, these are the secondary diagonal 3 5 7. So we can calculate by using this formula mat I n minus 1 minus I. Okay, so pick element from top right to bottom left. Okay, so here you can see I equals to 0 1 2. Okay, and I'm going to calculate this n minus 1 minus I. Okay, so this is the column n minus 1 minus I. This is the column and this is the row. Okay, so here you can see n is equals to 3. So here I am going to calculate n minus 1 minus I. Okay, so n equals to 3, and first of all our I value is 0, so n minus 1 minus 0 equals to 3 because I equals to 0 here, so we got 2. Okay, here you can see now we have I equals to 1. Okay, so here 3 minus 1 is already here in this formula, and I equals to minus 1, sorry, I equals to 1. So here minus 1, and answer of this is equals to 1. Okay, so here 2 1, and here again 3. Okay, n equals to 3 and minus 1, and I equals to 2, that is equals to 0. So we got 0 here, and now I'm going to find out matrix I n minus 1 minus I. Okay, so here you can see 0 row and column 2. Okay, so here you can see in 0 row, this is the 0 row. Okay, and column, this is the 0 column, this is the 1 column, and this is the 2 column. So 0 row column 2, so we got 3. 0 row column 2, we got 3. Okay, 3 top right element. Okay, now I am going to find out another element. Okay, so uh, this one. Okay, so here one row and one column. So this is our 0 row and this is our row 1. Okay, so row 1 and column also 1, so 0 or 1. This is the column, column 1 and column row. So we got 5 from here. Okay, middle element. Okay, and after that we need to calculate another. Okay, so here we have another element. So we have row equals to 2 and column equals to 0. So here you can see this is a 0 row, 1 row, and 2 row. 2 row, 0 column. Okay, so we got 7. Okay, so that's okay, so that I can calculate our secondary diagonal. Okay, so this is our secondary diagonal, 3 5 7. 3 5 7. 7 is the bottom left element. Okay, so secondary diagonal equals to 3 5 7. Now primary diagonal, top left, bottom right. Okay, so here you can see this is our primary, this is the formula for primary diagonals, matrix of I and I. So we got 1 5 9. Okay, so here I'm going to calculate also this. At 0 and 0, 0 row 0 column, we have 1. Okay, so this will give you 1. And now 1 row 1 column, so this is a 1 row and 1 column, we have 5. Okay, so here we got 5, and here again row 2. Okay, here row 2 and column also 2, so this is 9. 1 5 9. Okay, so this is our, these are our primary diagonals and these are our secondary diagonals. Okay, now I'm going to calculate its sum. Okay, so 3 plus 4, so sorry, 3 1 plus 3 is equals to 4. Now 5 plus 5 plus 4 equals to 14. Okay, now 9 plus 7 plus 14 equals to 30. Okay, and okay, so this is the sum of these. Okay, so now n equals to 3 odd. Okay, so we are going to take matrix 3 by 3, so that's n equals to 3, that is odd. Okay, so now middle element mat 1 1. Okay, at 1 row and 1 column we have 5. Okay, so count it twice, so it will counting, I mean it will count twice, so I need to subtract 1 5. Okay, so final sum equals to 30 minus 5 equals to 25. Okay, so these are the primary diagonals or these are the secondary diagonal. I hope you got it. Now I am going to write code for this. So here from typing I am going to import list, and here I am going to create class equals to solution colon, and here I am going to define one function, define diagonal. This one, this is the function df, define diagonal sum. Here I am going to write self argument, and here I am going to pass another argument, that is matrix should be in list. Inside the list we have list, and these list should be in integer int. Okay, and output should be in integer. Okay, so this is our function. Okay, so now I am going to calculate its length. Okay, length n equals to len, length of matrix mat. Okay, so here total equals to 0. Initially we have total equals to 0. Okay, now I'm going to apply loop for I in range of n. Okay, now total plus equals to mat of I and I. This is for primary diagonals. Okay, I'm going to calculate I'm going to calculate total for primary matrix, sorry, for primary diagonals. Okay, going to calculate total for primary diagonals, this one 159. Okay, now I'm going to calculate total for secondary diagonals. Okay, so mat I, here I am going to pass n minus 1 minus I. Okay, this is for second element, second diagonals. Okay, now I want to remove, because n equals to 3, so 2 appear twice. 2 counted at 2 time. I mean 5 counted twice. Okay, so I want to calculate it at one time, not at 2 time. So I need to exclude it. Okay, so if if n divided by 2 equals to 1. Okay, this is for, like, if you have matrix odd. Okay, so we have length of matrix is 3, so n is divided, like 3 divided by 2, we got 1. Okay, so here now I'm going to subtract total equals to total minus equals to matrix. Okay, in matrix I'm going to subtract ny2. Okay, that is a middle element. Okay, ny2. Okay, this is the middle element, that is 5, this one. Now I am going to return what? Return total. Okay, so I have completed this. Okay, this is the diagonal function. Okay, here I'm going to pass matrix that is in list inside the list. Okay, and here list should be in integer and output should be in integer. This is the length of matrix, and total initially we have 0, and for I in the range of matrix. Okay, in this matrix. Okay, and this is for first primary diagonal, and this is for secondary diagonals. If n divided by 2, like if you have odd numbers matrix, then you need to subtract mat ny2 this thing. Okay, now return total. Now I am going to test this. So here you need to take this thing from here to there, here, there to here. Solution equals to solution and print sol dot diagonal sum. Okay, and these are the matrices sol dot this function. Okay, and this is the object for class solution. Now I am going to run this. So I got 25. That is our answer. I hope guys you got it. I'm going to end the share screen. Okay, so if you like my video, please like, comment, do like, comments, and share. Bye bye. Take care.